And good morning, grade nines. Happy Easter. Welcome back. For those who are traditional only, welcome back. And for the year-round students, if you're watching this, enjoy your another week of vacation. I hope for the traditional, I hope you had a good break, 1 week of rest. And we'll be working on topic two for space unit, and this topic two is about space exploration. So we'll be looking at things that scientists use for exploring space, like the vehicles, telescopes, those things. Okay, so for today we'll start with topic two. How do you get in space, right? So what is space, right? So space is anything outside the Earth's atmosphere. And that's why we refer to it as outer space. How do you get into space? Obviously, you need a rocket for that. So, why can't be any other vehicle like an airplane, a jet, a fighter plane, like those things? Well, the thing is, you need something that is more powerful, something that will be able to carry a lot of fuel in order to continuously fight against gravity. So, like the pull of gravity. So that's the reason why you need a rocket. So you need to overcome the pull of gravity. That's why they call it rocket science, because it's very difficult. It's a delicate balance between a lot of variables. So we'll start with this one. So first rocketeer is this guy here, Wan Hu, and that was 2000 BC. So what he did, he attached a lot of firecrackers here. Yep, yeah. I want to say the S word, but it's not. It's not going to be appropriate. But yeah, so what he did there is, yeah. Okay, so simple rockets. So that's what he did, and he was never seen again after he lighted up those fire those rockets, those small rockets. Um, Simple rockets. We have this. It is made of pigeon. So basically, what they did is it's a model pigeon with water inside, and then a steam coming out of the pigeon, allowing it uh, to move really fast. So it's like, if you can visualize it, it's like after blowing up a balloon, and then you release the air, right? So the same thing with this one. So the pigeon will be the model. It has something like a heating something. It has something that will heat it up in order to produce steam. Now the steam will be released through the behind of the pigeon, and then it will now start to move. So that's the idea. The Chinese then invented this the rockets here, gunpowder. They used gunpowder for this one. So gunpowder was used to make uh, rocket propelled arrows. All rockets are based on Newton's third law of motion. So for every reaction, there's an equal and opposite reaction, like this one. So this guy here is pushing on the wall, and then the wall is pushing back. That's the reason why he's moving. Or if I'm doing this and pushing against each other, my hands are pushing against each other, then this force is equal to this amount of force. Now, if this will exert more force, then it will go this way. If this will exert more force, then it will go this way. So, um, so that's the third law of Newton, right? So for every force, there's an equal opposite force, or for every action, there's an equal and opposite reaction. So for rockets, they use gas under pressure. So as the gas is ignited, now the gas that is escaping now starts to push on the ground. Opening in chamber allows gas to be released. So thrust is created, now pushing up. So it's going up now. Rocket is propelled in opposite direction. So wherever the direction um, of the gas that is escaping, that's the opposite of the direction of where the rocket is going. So like in this illustration here, if the gas is going this way, then the rocket will be propelled upward. Makes sense. Okay. Rocket structure. So you have the structural and mechanical elements. So you have the body, the fins, engines, and storage tanks. So you have the fuel, um, Okay, you have liquid oxygen. Some rockets they even have solid fuel. If you will, if you've seen Bill Nye's space exploration, he also mentioned there that there are um, rockets with solid fuel payload. Okay, so the things that they need to deliver, um, and all other materials carried or needed for the flight. So that's what is needed. So this will be the fuel area. You will see a lot of like rockets. They will like with the space shuttle. You will have three. Well, yeah, at least maximum I think will be three fuel containers, and that will make the space vehicle really huge. The rocket really huge because of the amount of fuel that they need to carry. Villa, you've seen that. So the first one is launch of modern space age. This will all be just numbers. Just a quick review of the things that the things that like scientists decades ago did try in order to explore the space. Sputnik 1 launched October 4, 1957. Yeah, it was launched by the Russian. This actually started the space competition between Russia and the United States. So when Russians did this, okay, so what did the Sputnik do? It is part of the Cold War between the United States and Russia. So basically, it's a spy. It is a spy gadget for Russians to use, right? For them to monitor what's happening, right? Ignited the space race, and we have that helped identify the density of the upper atmosphere and provided data on radio signal distribution. So first opportunity for meteoroid detection. So this is where they will see if there are external threats like meteoroids outside the atmosphere. Okay, and then in order to maybe somehow prevent that from hitting the Earth if it's really that big. Sputnik 2 launched a month later, carried Laika, the first living creature sent into space. So we have this dog here survived for 7 days while orbiting the Earth. Okay. And a lot of us will not agree, obviously, with what they did. They could have just, do an unmanned or something that does not have any life form in it, right? Someone made a sacrifice for that launch. Next one, Canada's first round was Black Brant 1. That was September 5, 1959. Launched into Arctic sky over Fort Churchill, Manitoba. And Apollo program. Okay, designed to land humans on the moon and bring them safely back to Earth. So they did 6 missions there to achieve the goal. Neil Armstrong and Buzz Aldrin. So they're the first one to land on the moon. And remember Buzz Lightyear, okay, the toy from the Toy Story. Yeah, and Neil Armstrong is the first one to walk on the surface of the moon. So lunar surface experiments included soil mechanics, meteoroid seismic, heat flow, lunar ranging, magnetic field, solar wind experiments, and a lot of those things were conducted on the surface of the moon. Mainly because of the differences in maybe in the gravity, the materials present on the surface of the moon. Beyond the rockets. So why develop technologies beyond basic rockets? They needed a way to get humans into space for an extended period of time. Needed a vehicle that would last longer than one trip. And it's actually very costly. Imagine a fuel container that is 120 meters long, right? And it's really wide. So imagine the amount of fuel, and those are only one time use, like for only one time use. So we're wasting. I mean, space exploration is like really wasting a lot of money, right? So they need to find a way to reuse those materials. So space shuttles. Okay, so now they have the space shuttles here. Okay, this is what I'm talking about. So you have your solid rocket booster, another solid rocket booster. So this tank here contains um, liquid fuel. World's first reusable spacecraft will be this one. Could carry large satellites to and from the orbit. Launches like a rocket. maneuvers in orbit, lands like an airplane. So basically, what this thing do is go to space, orbit outside the Earth's atmosphere, and come back, and hoping that they will be able to reuse it again. Um, Five space shuttle orbiters were originally built and operated. First one is Columbia. Okay, Challenger is the second one. Discovery, but the problem with this one, um, it did explode 73 seconds after liftoff. So that's Challenger. That's 1986. Okay, Discovery from 1984 to 2011. It is retired already. Endeavour and Atlantis, they are all retired, mainly because they're pretty old, right? Designed to fly at least 100 missions each. Altogether, they flew a combined total of 135 missions. So that's a lot. Shuttle program was closed 2011 with the final flight return of Atlantis. Um, yeah, and then maybe they realize that we are spending a lot of money and learning what we're getting what, right? We're just getting pictures and those things, and maybe they need to. They realize that maybe the money can go to a better program or project instead of spending them on space shuttles. The space shuttle consists of three major components. Orbiter housed the crew. So this part here, it is reusable. Two solid rocket boosters, and so this most of the lift during the first 2 minutes has to be solid because when it becomes hot, it becomes liquid, and now it's easier to burn, right? If it's liquid or gas already, then it can run out quickly, right? It is reusable too. External tanks contains the liquid oxygen. Okay. And Columbia Space Shuttle disaster beginning of the space shuttle program. So the Challenger here, you can just go to YouTube and YouTube Space Shuttle Challenger, the disaster that happened there, and then Columbia followed after, and then they end the space shuttle program. Now, for PAT practice, you will not be taking your PAT, but this is I think is worth answering to. A blank consists of stars, planets, dust, which are formed from a blank. So if it consists of stars, planets, and dust, then you only have one constellation will be composed of stars, but it doesn't have planets, so this is wrong. Nebula obviously is the start, right? So this is wrong. So now you have two possible answers: galaxy. Now, which are formed from, obviously galaxies are not formed from constellations, they are formed from nebula, and letter C is the right answer. Enjoy the rest of the day. um, and you know what, and then continue to pray that this will all be over soon, and stay at home, be safe, be healthy, and honor your parents all the time. God bless you all. Love you. I miss you.